Equation of path of a projectile. The shape of the path of projectile can be found by mathematical equation. From x equal to v naught x into t is equal to v naught cos theta naught into t, we get time is nothing but x by v naught cos theta naught. This is equation 1. Therefore, y is nothing but what? V naught sin theta naught into t minus half gt square. Now if you are going to substitute the value of time here, it becomes y equal to v naught sin theta naught. In place of t, write this value. So x by v naught cos theta naught minus half into g into, in place of t square, again please substitute this value, x by v naught cos theta naught whole square. On simplification, y is equal to, now v naught gets cancelled here, sin theta naught by cos theta naught is nothing but tan theta naught into x minus, if you are going to do the square, you are going to have g divided by 2 into v naught cos theta naught whole square into x square. Since g, theta naught and v naught are constants, the above equation is in the form of y equal to ax minus bx square, where a is nothing but tan theta if you compare these two equations, and in place of b you have g by 2 v naught cos theta naught whole square. The above equation is the equation of a parabola. So the path of projectile is nothing but parabola. So this is how we are going to determine the path of a projectile by using an equation. Time to reach maximum height and time of flight of a projectile. Let Tm be the time taken of the projectile to reach its maximum height and Tf be the total time of flight of the projectile. At the point of maximum height, at time t equal to tm, Vy is equal to 0. In the projectile we have seen that at the maximum height, the vertical velocity becomes 0. So, if you take this equation, Vy equal to v naught sin theta naught minus gt, now here the value of Vy becomes 0, so 0 equal to v naught sin theta naught minus gtm. From this you are going to get the time as v naught sin theta naught by g. At t equal to tf, that is the total time taken, time of flight, y equal to 0, that means the vertical displacement becomes 0, because you are going to throw the object from x, again it reaches the x point alone. So what is the value of y? 0. So if you use this equation, y equal to v naught sin theta naught into t minus half gt square. Now here y becomes 0, so you substitute this value, v naught sin theta naught into tf minus half gt f square. If you rearrange, you are going to have the equation of time as 2 v naught sin theta naught by g. Now if you compare these two, this is the time taken to reach the maximum height, this is the total time taken to remain in air. That means from ground, again it should reach the ground. So if you see, the total time taken is equal to twice the time taken to reach the maximum height. So note that Tf is equal to 2 times of Tm because of the symmetric nature of the parabolic path. Maximum height of the projectile. How can we determine the maximum height? Let hm be the maximum height of the projectile after time Tm. So if you use the equation y equal to v naught sin theta naught into t minus half gt square and substitute the value of Tm in this, you are going to have the equation as hm is nothing but the maximum height equal to v naught sin theta naught into, in place of t, that is Tm value, v naught sin theta naught by g minus half into j into v naught sin theta naught by g whole square. If you substitute, you are going to have the value as hm equal to, that is the maximum height equal to v naught square sin square theta naught by 2g, because 1 minus half is nothing but what? Half alone. That's the reason. Another method, at h maximum, the vertical velocity becomes 0. You can use it first equation or third equation of motion also. That is v square minus u square equal to 2as. So here vy square equal to v naught square sine square theta minus 2gy. So if you substitute the value of Vy as 0, you're going to have the equation as Hm equal to V naught square sine square theta naught by 2g. So any one method you can use to find the maximum height of a projectile. Range of projectile. What do you mean by range? Range is nothing but the horizontal distance traveled by the projectile is called the range. Let r be the range of the projectile after time tf, that is the time of flight. It is the horizontal distance covered by the projectile from its initial point to the final point where it passes y equal to 0. I repeat, range is nothing but the horizontal distance covered. X equal to v naught x into t, where t is nothing but what? Time of flight. V naught is nothing but v naught cos theta naught. So if you substitute the value of time of flight, it becomes r is equal to, because x is nothing but what? Horizontal range, equal to v naught cos theta naught tf. So r equal to v naught cos theta naught into, what is the value of time of flight as we have calculated? It is 2 v naught sin theta naught by g. So r equal to v naught square sin 2 theta naught by g, because 2 sin theta cos theta is nothing but what? Sin 2 theta. That's the reason, sin 2 theta naught by g. V naught into V naught is nothing but V naught square. Note that the range will be maximum for the maximum value of sine. Where the value of sine is maximum, for 90 degree it is maximum. So when sine theta becomes 1, that is sine 2 theta becomes 1, this is possible when theta naught is 45 degree. Therefore, the maximum horizontal range is Rm is equal to V naught square by g. When theta is 45 degree, maximum height becomes V naught square by 4g. You substitute the value in the equation, we'll get the answer as V naught square by 4g. And range Rm is equal to 4 times of Hm, that is maximum height. So the range is equal to 4 times of maximum height actually. Range of projectile is same for complement angles of projection. We know that the range is nothing but V naught square sine 2 theta naught by g. Now if you take the coordinate system, it is a linear line which is 45 degree exactly in the middle. I am going to throw an object here like this by making an angle 45. So this is the horizontal distance traveled by the projectile. Now I am going to change the angle a bit, that is R maximum actually. So if I change the angle, so you can see that the range is not maximum, it is less than 45 degree. So let it be alpha. Another angle. So for angles 45 plus alpha and 45 minus alpha, 2 theta naught is 90 plus 2 alpha and 90 minus 2 alpha, because here it is 2 theta, right? So theta naught is nothing but what? 45 plus alpha or 45 minus alpha. So if you multiply this with respect to 2, you're going to have the expression as 90 plus 2 alpha and 90 minus 2 alpha respectively. The value of sine 90 plus 2 alpha and sine 90 minus 2 alpha are the same and are equal to cos 2 alpha. So therefore, the ranges are equal for elevations which exceed or fall short of 45 degree by equal amount of alpha. That means if you take more than 45 or less than 45, the elevation will remain the same, the range remains the same. In other words, for complement angles of elevation, the ranges will be the same. That is, for theta naught and 90 minus theta naught, the values of sine 2 theta naught and sine of 180 minus 2 theta naught are the same.